Hello, I'm an old guy and I do maths. Today we're going to try and find the point or points of intersection of the graphs of these two functions. And that essentially means where is it that this function is equal to this function, which may be a hint about how we proceed here. This is done by way of a simultaneous equation. So essentially what we're dealing with is simultaneous equations involving quadratics. Now, I find it extremely useful to set up a diagram of what it is I'm looking for. So on my yellow pad, what I've done is I've very, very roughly sketched each graph, sketched the graph of each equation. Now this one was in turning point form, so it made life a little easier. Now this is not to scale. It may be that this intersection could be out here somewhere. It's just to give me an idea of what I'm looking for. And it seems as though I'm looking for a couple of solutions to this. So what we're looking for is this point here, the coordinates of this point here and the coordinates of this point here. And our answer is probably going to be, I suspect it's going to be quite ugly. So rather than work this all the way through to finding both coordinates, what I will do is I will find the x coordinates, and then I will say something like, and in order to find the y coordinates, put your x coordinates into this equation or this equation. And it's just so that the video doesn't get too long and you don't get bored watching me work out what y equals. But that's the process. So we're going to truncate this by simply finding these x coordinates of this these points of intersection, which, by the way, is in fact the solution to where this equals this. So in a roundabout way, we're not shortening this, but I've probably spent so much time talking about that this is going to be as long as it would have been anyway. So that's what we're looking for, those two x points. Okay, let's get to work. Right, so this is basically a simultaneous equation, so therefore what we are going to do is we're going to make this equal to this, create a quadratic out of that, and solve that quadratic. Okay, so my first step is to expand this. So let's get to work on that. So this is negative x squared plus 4x plus 4. And when I say negative, I talk about this. So we're going to eventually multiply this by negative 1, and all of these terms will become negative, plus 2. So this is the expansion of that. The negative is out the front and the 2 is here. So let's tidy this up, or work our way through it. So it's negative x squared minus 4x minus 4 plus 2. Okay. Which will give us negative x squared minus 4x minus 2. And we'll take this equation here and just write it here, plus 5x plus 6, and we're going to make these two equal. Right, so that's a little bit of rearranging. So x squared plus x squared, so we add x squared to both sides, plus 5x plus 4x, we add 4x to each side, 4x plus 6 plus 2 is equal to 0. Now, what does that work out to? That works out to 2x squared, 5 and 4 is 9, plus 9 x, 6 and 2 is 8, plus 8. And that equals 0, and we're going to solve this equation. And in solving this equation, we will find the two x coordinates of these points of intersection, and therefore solve the problem of what value of x, or what values of x, will make this equal this. Okay, let's go to work. But there's one thing that I'm going to do first. I'm just going to check that I do have two solutions for this, and for that I'm going to use part of the quadratic formula. Now I'm going to use the quadratic formula anyway, so I'll write it in here just for the sake of completeness. So that is b squared minus 4ac all over 2a. Now what I'm going to do is I'm going to use the discriminant. I'm going to use this part of this to check that I have two solutions. So that is b squared minus 4ac. And what that is in real terms is b is 9, so that's 81, minus 4, a is 2 times 2, and c is 8. So that is 81 minus 4 2s are 8, 8, 8, 64, 81 minus 64, which is 17. Now, that's a positive number, so there's going to be a positive number in here. We're looking for the plus or minus the square root of 17 in here, and that tells me that there are two solutions. When this number is positive, there are two solutions. Okay, well, I have probably short-circuited quite a bit of work by just dealing with the discriminant. So this, by the way, is the full formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, we know what this is. We know that in the radical here, in the square root sign, we have 17 plus or minus. We know what b is. B is 9, so if we make that negative 9, we've got the top row of this formula worked out already, and a is 2. 2 times a is 4. X is equal to this. Negative 9 plus or minus the square root of 17 over 4. There are two solutions. X is equal to negative 9 plus root 17 over 4, or negative 9 minus root 17 over 4. Now those are the two x coordinates of these points, and as I said earlier, I was going to try and keep this video a little bit shorter than it would necessarily have been had I put these back into one of our original equations. And I hope you'll forgive me for not doing so. But if you want to find the y coordinates of the points of intersection of those two graphs, you put this and you put this into one or other of these equations here, and you will get those y coordinates. Forgive me for not doing so. I hope this was useful, and I'll see you next time. Bye.